So one of the most critical ideas that we can understand in terms of describing an object's motion is understanding the relationship between the object's velocity vector and its acceleration vector. So again, just to remind ourselves, acceleration is how an object's velocity is changing with respect to time. So the acceleration vector is going to tell you how the velocity vector is changing. So what are the options that we have for changing the velocity vectors? Well, there are three ways that we can change the velocity. You can speed up, you can slow down, or you can change its direction. So the first two of these, of course, are really changing the magnitude of the velocity vector. Speeding up means you're making the velocity vector's magnitude longer. Slowing down means you're making the magnitude of the velocity vector shorter. Changing its direction, on the other hand, is turning. So for the moment, let's start by just thinking about one-dimensional motion. So let's take turning off the table for a moment. We'll come back and add it in a little bit. But let's start by just thinking about objects moving along a single line, where basically speeding up and slowing down are the two possibilities. Now, to be clear, if we just have one-dimensional motion, an object turns around, we might think of that as changing its direction. The better way to think about that, it's true that you are changing the direction of the velocity because the sign is changing. If the object was moving in the positive direction, it's now moving in the negative direction when it turns around. Probably the better way to think about that, though, is not really a change in direction as much as it is a transition from slowing down to speeding up. So we'll see why I'm trying to draw that distinction when we come back and talk about changing its direction as turning in a little bit. But so for the moment, we're going to focus on sort of the speeding up and slowing down in terms of how the velocity vector and acceleration vector relate to each other to describe these two things. Now, for starters, there are often some words that we use, and we use them in everyday language, synonymously with speeding up and slowing down. So we will often say accelerate to mean speeding up, and we will say decelerate to mean slowing down. And it's not that you should never use these words. It's not that these words are horrible things. They're not as scientifically clear as we would like for them to be. So the reason for this is that both speeding up and slowing down are forms of acceleration. So to talk about something accelerating means that it could be either speeding up or slowing down. So what we want to do, and here's the interesting argument that I'm going to make, is that even though accelerate and decelerate potentially sound fancier, speeding up and slowing down are really the clear technical terms. And so we just want to understand what it is that speeding up and slowing down are really trying to communicate. Well, let's start with speeding up. Okay? So if I want to think about speeding up or slowing down, what I'm really thinking about is the relative direction between the velocity and acceleration vectors. So for speeding up, let's start there. So here's my car, and let's say I have some image of it initially, some image of it at the end, so I know that at some initial point in time, it has some velocity vector that we've labeled v initial. At some final point in time, it's got a different velocity vector. We've labeled it v final. And the thing that's clear, because my object is speeding up, is that the magnitude of that velocity vector is increasing. Velocity vector is clearly getting longer. That's what speeding up means. But how this happens is because the acceleration vector also points in the direction of the velocity. So in this case, my car is moving to the right. Both velocity vectors point to the right. The acceleration also points to the right, which is why the acceleration vector, or why the velocity vector is getting longer. So speeding up is really telling us two things. The first is that the magnitude of the velocity vector is increasing. That's the one that we probably, from sort of everyday language, that's the one that we typically think of. The important detail that we need to make sure that we add to our understanding of what speeding up means, though, is it's also telling us that the velocity and acceleration vectors point in the same direction. So objects speed up because the acceleration vector points in the same direction as the velocity. What about slowing down? So again, here's my car, comes through. I've got some initial point in time where I know its velocity vector. I've got some final point in time where we've drawn out its velocity vector. And of course, the key detail here is that velocity vector is decreasing in magnitude. So obviously one thing that I know is slowing down is telling me that my velocity vector's magnitude is decreasing. The reason it's decreasing is because the acceleration vector points in the opposite direction. So again, slowing down, just like speeding up, is telling us two different things. The first one is it's telling us something about the magnitude of the velocity vector. In this case, slowing down means the magnitude of the velocity vector is clearly decreasing. But the second thing it's telling us is that its magnitude, the velocity vector's magnitude, is decreasing precisely because the acceleration points in the opposite direction as the velocity. So objects slow down when the velocity and acceleration vectors point in opposite direction. If I now have objects that are traveling at a constant speed, what does that mean? Well, same car, traveling at a constant speed means that the magnitude of the velocity vector doesn't change, right? So whatever length it is at my initial point in time, it's that same length at all the points in time afterward, including at the final point in time that we've drawn here. This happens because the acceleration is zero. So traveling at a constant speed, again, tells me two pieces of information. And again, I'm going to add in the constant speed in a straight line. And we'll see why that detail matters when we start to think about our turning here in a minute. But constant speed in a straight line is telling me two things. One, of course, is that the magnitude of the velocity vector is not changing. Whatever its magnitude is, that magnitude stays the same as it moves across in a straight line. It does that because there is no acceleration. So the acceleration vector has a zero magnitude. That's why our object is able to move in a straight line at a constant speed. So why is it that this is useful? The reason it's useful is because it's actually going to be important as we go forward in the class thinking about solving not just kinematics problems but also dynamics problems. It's going to be incredibly useful to think about the direction of the acceleration. And so we're able to use this information that we have about the object's motion to help us think about the direction of the acceleration. So the first thing we're going to do is figure out which way the object's moving. That's going to tell us the direction of the velocity. The second thing we're going to do is figure out, well, is the object speeding up, slowing down, or traveling at a constant speed, because that will help us figure out what the acceleration is. So if I know my object is moving to the right, and it's speeding up, then I know the acceleration vector also has to point to the right. If my object is moving to the right and slowing down, the acceleration vector has to point to the left. If my object is moving to the right at a constant speed, then the acceleration vector has to be zero. And so we want to actually get really good, because this will be critically important in terms of solving these motion problems, for solving these mechanics problems. It's going to be really important to figure out what the direction of the acceleration is. So we want to be good at understanding how we can use speeding up, slowing down, and traveling at a constant speed as one piece of information to help us do that.